So before we start with today's session, let's look back at some previous learning and let's have a look at this image. Now we can see we've got two bar models and we're told that the very top bar model has one half shaded, one of two parts. Can we use that information to find out what fraction of the bottom bar is shaded? Remembering that these are going to be equivalent fractions. So we've got the top bar that shows us one half. So what fraction of that bottom bar, which is equivalent to one half, is going to be shaded? So pause the video and see if you can work out what the answer to this one's going to be. So we can see the answer to this is going to be 5/10, because if we were to draw a line down and measure exactly the same length as one half, we would get 5 of those tenths in that space. Another way of looking at this could be 2 multiplied by 5 gives me 10, which is my denominator. So my numerator means 1 times 5 gives me 5. What I do to the denominator, I must do to the numerator. And what I do to the numerator, I must do to the denominator. So the answer to this question is 5/10 is equivalent or equal to 1/2. Now in this session, we're going to continue to develop our ability to find equivalent fractions using our reasoning. So we're going to be using diagrams, number lines, but also we're going to start moving on to the idea of using those known facts and applying multiplication and division to being able to check whether fractions are going to be equivalent. So this means when we can see the fractions are going to be equivalent or not equivalent using our bar models, our number lines, our fraction wall, that's when we're going to be able to take a slightly shorter cut where we're going to apply our abstract knowledge of this to be able to work out. There's going to be a little strategy that we're going to investigate in this session. So turning to our textbook, we can see that our first question is relating to Rena and Danny's mathematical problem. And we can see that Rena is thinking that she's making fractions that are equivalent to 1/2 using the number cards that she has. So for question 1a, we're asking how can Rena use her remaining cards to complete the puzzle? So she's already worked out 1/2 and we've got the idea of equals, which is the idea of the equivalent fractions, meaning the same as. And we're going to be looking for a fraction that is going to be the same as 1/2 or equivalent. So using the number cards of 3, 4, 5 and 6, how can we select the cards to be able to work out what our fraction should be? For question 1b, we're told Danny's going to use 4 of his cards to make 2 other equivalent fractions. So how can Danny complete his puzzle? And one of the things that we need to be thinking about on this is what fractions can we actually make out of those 6 cards that Danny has? Because we need to be thinking about that initially in order to find fractions using those cards which are going to be the same. So for question 1a, we're going to be looking at how can Rena use her remaining cards to complete the puzzle. 1/2 equals another fraction. And for question 1b, Danny uses 4 of those cards, 1, 2, 3, 4, 5 and 6, to make 2 other equivalent fractions. How could Danny complete his puzzle? So pause your video and try and solve those first 2 problems, and then come and join me when you're ready so we can discuss the strategy that you've been using. So let's begin by looking at question 1a. And our question here is how can Rena use her remaining cards to complete the puzzle? Now we know that Rena's got 1/2 and it's going to equal another fraction. And we know that fraction is going to have to use the numbers 3, 4, 5 or 6. So if we ignore the numerator just for a moment, what we can think about is we're going to be looking for an equivalent of 1/2 to thirds, quarters, fifths and sixths. And if we create our bar models or use our fraction wall, we'll be easily able to do it. So we can see with the fraction wall in front of you, I've created the halves, which we know that Rena's already working with, and then I've created those thirds, quarters, fifths and sixths. I haven't worried about my equivalent fractions yet. That's going to be my next stage. Now we can see that I've shaded in 1/2 of my top bar. And what I'm now going to be doing is I'm going to be using my fraction wall to find out which fractions are going to be exactly the same size as that 1/2. This means they're going to be equivalent. Now looking at my fraction wall, we can see ones which are exactly the same size. So if we look at the thirds, for example, we can see that 1/3 is less than 1/2, but 2/3 is greater than 1/2. If we look at our quarters, we can see that 1/4 is less than 1/2, but 2/4 is exactly the same. If we look at our fifths, we can see that 1/5 is less than 1/2, 2/5 are less than 1/2, but 3/5 are greater than 1/2. And if I was to look at my sixths, we can see 1/6 is less than 1/2, 2/6 is less than 1/2, but 3/6, well, that's exactly the same as 1/2. So when we're looking at Rena's problem, using these ideas of her cards, how can Rena use her remaining cards to complete the puzzle? Well, 1/2 is the same as 2/4, and 1/2 is the same as 3/6. Now, if I was to look at the cards that Rena has, we can see that I've got a 3, 4, 5, and 6. Now, this means that I can't have 1/2 equals 2/4. I don't have a 2. However, I do have a 3 and a 6, so I can say, using Rena's cards, my answer must be 1/2 equals 3/6. Now for question 1b, we're asked, Danny uses 4 of his cards to make 2 other equivalent fractions. How could Danny complete his puzzle? So the first thing we know is Danny's going to make different equivalent fractions. So he's not going to have 1/2 and 3/6. That's a guarantee. However, he could have 1/2 is equivalent to thirds, 1/2 is equivalent to quarters, 1/2 is equivalent to fifths. So the very first thing that I need to look at with this is, what fractions can Danny actually make out of his 6 cards? So the first thing that I'm going to do is create as many fractions as I can using these cards. So the first set of fractions I've done is unit fractions. So I've done my numerator as 1, and then I've made as many denominators as I can. So you can see that I've got 5 different fractions that are unit fractions with 1 as the numerator. So now I can move on to my next. Now I've created my first set of non-unit fractions using the number 2 as my numerator. And next we've got my non-unit fractions with a numerator of 3. Notice how halves have vanished, thirds have vanished, because what I don't want is to make whole numbers or improper fractions. I only want to have unit and non-unit proper fractions in this instance. And next we have our numerator as 4, so 4/5 and 4/6, and finally our final proper fraction of 5/6. So out of those 6 cards we can make 15 different fractions. Now our next stage is going to be to see whether any of these fractions are equivalent. Now my first thing I can do is to create each fraction on my fraction wall. So if we take that first example of 1/2, we can see that Rena created 3/6, but we can also see that it was 2/4. There was another fraction that could be allowed. And we can see that Danny could have made 2/4 out of his cards. The only problem we have here is if he's already used the 2 for the denominator of 1/2, he can't use the 2 again for 2/4. But we can start playing around with our fraction wall to check equivalent fractions for 1/2, equivalent fractions for 1/3, equivalent fractions for 1/4, equivalent fractions for 1/5, equivalent fractions for 1/6, and so on. And as long as we haven't used the same digits twice, we know that they're going to be equivalent. Alternatively, I've got a method where I can use my multiplication facts. So if I'm looking at 1/2, if I'm using 2 as my denominator, what I'm able to do here is work out different multiplication facts that will help me be able to do it. So we know that 2 times 2 gives me 4. So halves, we can find something within quarters which are going to be the same. If we take our numerator as 1, we've just multiplied our denominator by 2, so we're going to multiply our numerator by 2. So 2 times 2 equals 4, 1 times 2 equals 2, so we're saying here that 1/2 is the same as 2/4, which we've already seen. I could say 2 times 3 gives me 6, so the denominator times 3 gives me a denominator of 6, so my numerator times 3, in this case 1, is going to give me my next numerator. So it's going to show me that 1/2 is the same as 2 times 3 is 6, 1 times 3 is 3, so 1/2 is equivalent to 3/6. And we can see on our fraction wall that is true. 1/2, the denominator multiplied by 2 gives me 4, the numerator multiplied by 2 gives me 2, so 1/2 is equivalent to 2/4. 1/2 the denominator multiplied by 3 gives me 6, the numerator multiplied by 3 gives me 3, so 1/2 is equivalent to 3/6. If I was going to be looking at multiplying it by 4, 2 times 4 gives me 8, so that gives me 8. 1 times 4 gives me 4, so 1/2 is equivalent or the same as 4/8. So we can start looking at these new fractions like this. And here we can see some of the fractions that Danny can make. We can see that if we take the 1/2, we multiply the denominator, in this case by 3, to give us a denominator of 6, and the numerator we have to do the same too, so we're going to multiply that by 3 to give us 3, and we can see that we've got the digit cards 1 and 2, and we've also got the digit cards 3 and 6, so that can be an equivalent fraction that Danny can make. If we look at 2/3, well, if I multiply my 3 by 2, 3 times 2 equals 6, which means I'm working with a denominator of 6 now, and what I've done to my denominator I must do to my numerator, so 2 times 2 gives me 4, so 2/3 is the same as 4/6, and if I look at my cards I can see that I've got a 2 and a 3, and I've got a 4 and a 6. If we look at 1/3, 3 times 2 gives me 6, so our denominator doubled gives me 6, and our numerator exactly the same is going to happen. 1 times 2 equals 2. So we can see that 1/3 equals 2/6. And of course, if we're saying that 1/2 is equivalent to 3/6 by telling us that the denominator times 3 equals 6, the numerator times 3 equals 3, we can work it on the inverse. So if we came up with 3/6 as our first fraction, or 6 divided by 3 gives me 2, 3 divided by 3 gives me 1. So 3/6 is equivalent to 1/2. So we've got two methods that we can be looking at here. We could be using our multiplication and our abstract knowledge, as we can see in front of us now, where I could be looking at 1/2 and I could be multiplying the numerator and the denominator by 2, multiplying them by 3, multiplying by 4, by 5, and so on. Or I could be using my fraction rule to visually see that these fractions are the same size, they are equivalent, but both rely on me being able to identify all the different possible fractions as my first point. So for question 1b, Danny needed to identify all the fractions he could make, and then once he'd identified them, he had those two options. He had option 1, use the fraction rule to visually identify which fractions are the same size, or option number 2, which is to use our multiplication or division method to actually work out the equivalent fractions for each by multiplying the numerator and denominator by the same amount, or dividing the numerator and denominator by the same amount. So now you're ready to move on to the rest of the questions in our textbook before moving on to that independent work in your workbook. So be thinking about that strategy. So looking at our first question from question 1, be thinking about all the different fractions you can make out of the digit cards 1, 2, 5 and 10, and then once you've found all those, then make that decision of, are you going to be using our fraction rule to see which fractions are going to be exactly the same amount, the same size, or are you going to be using that abstract method of multiplying the numerator and the denominator by the same amount to see which ones are going to be the same, or are you going to be using your division and dividing that numerator and that denominator by the same amount to find the equivalent fractions? Come back to the video should you get stuck on any of these methods, and good luck with today's work. I look forward to seeing how you get on.